Hello viewers, in this tutorial we will try to know how to detect multicollinearity problem using R programming. So multicollinearity refers to a situation in regression analysis where two or more independent or predictor variables in a model are highly correlated with each other. The multicollinearity problem badly affects the regression model and decreases its accuracy. In R programming language, multicollinearity can be assessed using various methods. Here we will use simple methods and follow some steps like determine the correlation matrix, and then we calculate the eigenvalue eigenvector pairs. Then from the eigenvalue eigenvector pairs we will calculate the condition number condition index value to detect the multicollinearity problem. We further calculate the variance inflation factor or and tolerance value to detect the multicollinearity problem. So detecting the multicollinearity problem, we will use the empty cars dataset. So let us run the empty cars datasets. The empty datasets is a built-in dataset in the R programming language which contains about information about various car models. So let us run the code. Okay, run again. So this is the data contains 32 observation and 11 variables. These are the car models and these are the variables. These variables elaborates mpg for miles per gallon, cyl for number of cylinders, then disp means displacement, engine displacement, HP means horsepower, DRT means the rear axle ratio respects the ratio of the number of revolutions the drive shaft makes to the number of revolutions the rear axle makes. WT for weights, then quarter mile time is the time taken by a car to cover a quarter mile distance from a standstill. It measures in second, and the rest other variables. Okay, so first of all let us determine the correlation matrix. So we will write this code for correlation matrix. Now we can write here print function to see the correlation matrix. Run it. Okay, this is the correlation matrix. We can also run this command to view this correlation matrix. So from the correlation matrix we can see that maximum variables are highly correlated to each other, so we can suspect multicollinearity problem here. So we will calculate the eigenvalue eigenvector pairs. So we can write the code here for eigenvalue eigenvector pairs from the correlation matrix. So we run it. So again run this. So we found the eigenvalue eigenvector pairs, but we don't need the eigenvector, we only need the eigenvalue. So we write this command eigenvalue then $values. So run it, and to see the value we run it again. So this is our eigenvalues. So using these eigenvalues we will calculate the condition number and condition index. So we know the condition number is the ratio of the maximum eigenvalues and the minimum eigenvalue. So we write the function here and run it. To see the condition number we run the code again. So we found the condition number is 299.7767. So to interpret this value we know that the condition number ranges between 100 to 1000. So if the condition number less than 100, then it indicates no multicollinearity, and if the condition number is greater than 1000, it indicates severe multicollinearity, and if the condition number ranges between 100 to 1000, this indicates moderate multicollinearity. Since 299 ranges between 100 to 1000, so we can conclude that our data set is moderately affected by multicollinearity problem. So now the condition index. So the condition index is nothing but the square root of condition number. So we write here square root of cn, then run it. So we found the condition index is 17.31406. So as similar, the interpretation is for condition index is that if the condition index value is less than 10, it indicates no multicollinearity, and if it's greater than 30, it indicates severe multicollinearity. Since this condition index value 17.31406 ranges between 10 to 30, it indicates moderate multicollinearity. So now we will calculate the variance inflation factor VIF value to detect the multicollinearity problem. So for this we have to run a regression model. So and for this we need a package called car package. So we first load the package library. Okay, the package is loaded. Now we will run a regression model. Since we have multiple variable here, so we assuming the MPG, miles per gallon, as the dependent variable and the rest are the independent variable. We feed a linear regression model here and run it. Okay, the model has been fitted. Let us check the summary of the model. We write summary, then the model name. Okay, so this is the model summary. This is the intercept value, and these are the slope value or beta values. So the calculation of variance inflation factor is very simple. We write the VI function, then the model. So run it. To see the value, we run it again. Okay, so these are the variance inflation factor. So how do we interpret these values? The variance inflation factor values ranges between 5 to 10, and any values in the range indicates moderate multicollinearity. So here all of the variables are greater than 5 except the drat variable, VS and AM variable. These three variables VI value is less than 5. So we can conclude that these three variables are not strongly correlated with any other variables, but the rest of the independent variables are strongly correlated with other variables or each other, which indicates multicollinearity. Now the tolerance value. Calculate tolerance value using by the following formula: 1 divided by the VIF value. So we write the code and run it. So these are the tolerance value. So if the tolerance value is close to 0, we can conclude that there is little or no multicollinearity. But if the tolerance value is close to 0, we can say that there is high multicollinearity problem. So by seeing the tolerance variables, we can conclude that there are moderate to high multicollinearity problem in the dataset. So this is the procedure how we can detect multicollinearity problem from a dataset.